Welcome again, Wildcats. All right, so today we're looking at Wednesday, November 30th, and we're looking at the characteristics of quadratics, and that's going to be on page 36. So if you would, pause the video and update your table of contents. All right, now that your table of contents are updated, let's take a look at your notes. All right, so the characteristic quadratics. So let's first look at when f of x equals ax squared plus bx plus c. Now, when a is positive, the quadratic opens upward. I've labeled the vertex, which is a minimum in this scenario, and I've labeled the y-intercept, which is 0, c. And the reason why I say 0, c is because this is your y-intercept value in the equation. The axis of symmetry is what cuts the quadratic or the parabola in half. And the way to find the axis of symmetry is you find your vertex. When you find your vertex, you'll find the axis of symmetry. The domain of a quadratic is all real numbers. And in this case, the range is y greater than or equal to the k value from the vertex. Now, in this case, when you have f of x equals negative ax squared plus bx minus c, the graph opens downward. And I forgot to write that, so let's write that now. Opens downward. All right, so here, because it opens downward, the vertex is a max. And this, I just changed the scenario so you can see that the y-intercept, when c is negative or minus c, the y-intercept would be 0, this is a minus c, okay, because it's below the x-axis. That has no effect of this being negative. I just put two scenarios in one, okay? This negative a is the reason why this graph is opening downward. All right, and again, the axis of symmetry is what cuts the parabola in half, and we know how to find the axis of symmetry because when you find the vertex, you'll find the axis of symmetry. The domain in this case is all real numbers, and the range is y less than. Now it's less than because it's opening downwards, and it's less than or equal to the k value from the vertex. All right, let me pause that for a minute so you can copy all that down. Now, you'll notice I use colors, and I recommend using colors in the video because it's easier to see the different aspects of the graph. I did this in pencil, and then I looked at it. It was just kind of hard to read everything, but once I started adding color, it started to kind of point out the important characteristics. All right. Now, there's two forms that we need to look at right now. There's the vertex form, which is y equals a parentheses x minus h squared plus k. And you notice that I'm aligning, I've always made, in this case, the a value pink, and I'm always doing the vertex in blue, so you can see how they connect in each part. So the vertex is hk. The axis of symmetry is x equals the h value of the vertex. And that, remember when I said to find the axis of symmetry, you find the vertex. So once you find the vertex, you find the h value, you'll find your axis of symmetry. Now, when the a value is positive, the direction is up and the vertex is a minimum. When the a value is negative, the direction is down and the vertex is a maximum. Now that's with vertex form. Now let's look at standard form. Standard form is y equals ax squared plus bx plus c. The vertex is h equals negative the b value divided by 2 times a. And the k value is equal to the focus, which we haven't talked about yet, times negative b divided by 2a. Okay, so we're not going to use this vertex form for standard form at the moment. Once I teach you the focus, then you can, but I wanted you to see, since I told you how to find the vertex in this form, I wanted you to see how the vertex was found in standard form. Now the axis of symmetry, when given standard form, is x equals h, and in this case h is negative b divided by 2a. Now in standard form, when the a value is positive, the direction is up and the vertex is a minimum. When the a value is negative, the direction is down and the vertex is a maximum. So if you would, make sure you get that down, and let me bring this back up so you can get that back down. All right, so there's vertex form, and then there's standard form. All right, so that should get your notes, but let me actually just, I know it'll take about 20-30 seconds, but my head might have cut some of the notes down, so let me just slide the notes up just gradually, so you can basically pause and then copy down what you need. Again, I'm just doing this just in case that my little picture in the corner cut off any of the notes. All right. Here we go. Now let's take a look at some of the examples. I'm just going to write down examples I'm going to go over. Don't forget that this is on page 36. All right, so let's look at example number 1. Now the vertex, I'm just going to label with a V, is your minimum or maximum. In this case, the vertex is 1, 1. Now the axis of symmetry is you draw your dashed line down the middle where the vertex is, and it's x equals. So in this case, x is the h value is 1, so x equals 1. It opens upwards, and you can just circle it. Circle that it opens upwards. What was that? Oh, that's the bell, sorry. All right. So the y-intercept, you find the y-axis, you follow along. So the y-intercept, I'm just going to mark with the y, is here, so that's 0, 2. All right. It's a minimum, and the minimum value is y equals 1. And the reason why we're saying that is because that affects the range. Okay, and the way I found it, for one, this is y equals 1 right here, but I can also find it from the vertex. So in this case, the domain is all real numbers. And the range, since it's opening upwards, is y greater than or equal to the minimum value, which is 1. All right, so let's look at example 2. Move it over. All right, so the vertex is either the minimum or maximum point. In this case, it's a maximum point. So the vertex is 4, 9. So again, the axis of symmetry cuts the parabola in half, and you find that by finding the vertex. So in this case, it's x equals the h value, which is 4. It opens downward, and then the y-intercept, find the y-axis, is this line crosses, it looks like, at -5, so the y-intercept is 0, -5. It's a maximum value, and again, we're finding it as a y because that affects when we find the maximum minimum, that affects our range. So our maximum is y equals 9. Okay, and our domain is all real numbers. And then the range, since it's opening downward, is y less than or equal to the maximum value, which is 9. Now, example 3, 4, and 5, you just have to graph in your calculator, which I feel like we can go over those in class because I don't feel like this is a very difficult concept. I feel like it's very straightforward. So I know you've requested lots of examples, but I think in this case, I think 2 examples is okay. But don't worry, we can go over all the examples or just 3, 4, and 5 in class on Wednesday. Okay? So with that, have a terrific Wildcat day.